Thanks for tuning in to Larkin TV, commercial free all the time. Okay, so we're going to do two example problems. I don't know why I'm talking like this. We're going to do two example problems of more difficult conversions. So what you should do is you should have a sheet of paper out and you should just be taking notes and following along. And then if you have questions that aren't answered in the video, you should come in office hours or ask a friend and have them explained so that you understand fully what's going on here. So number one. How many atoms of magnesium are in 150 grams of magnesium nitride? So it's asking atoms of magnesium, so I'm going to box that, and it's giving us 150 grams of magnesium nitride. So first thing I need to do is I need to find the formula for magnesium nitride. I know magnesium's Mg. I know nitride means it's nitrogen, so that's N. Magnesium has 2 valence electrons, it's going to lose them, form +2. Nitrogen has 5 valence electrons, it's going to gain 3. These aren't balanced, I need more positives. Now I need more negatives, so I add another nitrogen. I still need more positives. Now they're balanced. So the formula for magnesium nitrate is Mg3N2. Before I really go any further, I know I'm going to need that formula, so I just go ahead and do it. I know that I'm starting with mass, and I know I'm trying to end with atoms of Mg. So I have mass of Mg3N2. I know I'm going to go to moles of Mg3N2. And then I know I've got to get to atoms Mg, so I'm actually going to have to go to moles of Mg first before I can go to atoms Mg. So this is actually a 3-step conversion. Okay, so I'm going to start with my 150 grams of Mg3N2. First thing I'm going to do is I'm going to convert to moles of Mg3N2. So I put moles of Mg3N2 on top, and I put grams of Mg3N2 on the bottom. And now I need to find the molar mass. Okay, magnesium has a molar mass of 24 on the periodic table. There are 3 of them, so that's 72. Nitrogen has a mass of 14, so that's 28 plus 72. Wow, even 100, nice. So that's 1 mole for every 100 grams of Mg3. So the grams cancels out. 150 divided by 100 is just 1.5. I turned this down because I thought it'd be neater, but now I think it's going to be harder for you to see. So hopefully you can still read all that. I don't know if that's better. 1.5 moles of Mg3N2. Alright, I'm going to switch colors for the next step. So now I'm going to take this down, 1.5 moles of Mg3N2, and I'm going to convert to moles of Mg. So I want moles of Mg up here, moles of Mg3N2 down here. I know that there are 3 moles of Mg for every 1 mole of Mg3N2. That's what the subscript is telling me. This canceled. 3 times 1.5, that's 4.5 moles of Mg. So now I'm right here. I'm ready to go to atoms of Mg. So I'm going to start with my 4.5 moles of Mg times another conversion factor. I put moles Mg on the bottom, and I want atoms Mg on top. I know that for every 1 mole of Mg, there are 6.02 times 10 to the 23rd atoms. Alright, so you should be able to do this, the long way multiplication, but for the sake of the video and time, 4.5 times 6.02, so that's 27.09 times 10 to the 23rd, which is the same as atoms of Mg, which is the same as 2.709 times 10 to the 24th atoms of Mg. So there's my answer. That's how many atoms of magnesium there would be. which, ooh, boy, that's a lot of magnesium. Interesting. Alright, so three-step conversion here. This is probably the hardest type of conversion you'll get this unit. So if you can do this, if you can understand this, then you're in really good shape. Number 2, if there are 9.03 times 10 to the 22 molecules of sulfur trioxide in a sample, how much would the sample weigh? So it's giving us the molecules, and it's asking us the weight. So it's giving us the amount of sulfur trioxide. Let's get the formula. So this is covalent. There's no prefix for sulfur, so it's just S. And then oxide is oxygen, but there's a prefix of tri, which means 3. So the amount of SO3, and then it's just asking us the weight. So I guess mass of SO3. So I just go through moles. Okay, so I'm going to start with my 9.03 times 10 to the 22nd molecules of SO3. Use my conversion factor. I know I'm going to have molecules. Don't shorten it. I know it's tempting. Don't do it. I'm going to have moles on top because that's what I'm going to. 1 mole is equal to 6.02 times 10 to 23rd molecules. So molecules cancels here. 9.03 divided by 6.02 is 1.5. And then 10 that's actually 10 to the negative 1. So this is actually 0.15 moles of SO3. You could leave it in scientific notation if you wanted. It's fine. Let's not forget the units on this guy too. And now we need to go moles to mass SO3. So we have 0.15 moles SO3. And I have moles SO3 down here, and I need mass, so that's grams SO3. So this means I'm going to have to use my molar mass. So oxygen is 16 times, there's 3 of them, so that's 48, plus sulfur, which is 32, so that's a molar mass of 80. So 80 grams for 1 mole. And then for 80, we have 0.15 times 0.15 gives me 12. So that means there are 12 grams of sulfur trioxide. So it doesn't weigh a whole lot, but there's a lot of molecules because molecules are very tiny. Well, I hope you've enjoyed this episode of Larkin TV. And commercial free still. Amazing, right? I know. What a deal. I'll see you in class. Bye-bye.